Hello, Assalamualaikum warahmatullahi wabarakatuh. Madam Ruby here, logging in for lesson 49, Electrolytic Cell. We need to be able to explain the component and operation of electrolytic cell, explain the influence of the following factors: concentration of the species and standard electrode potential of the species. And then we have to explain the electrolysis of molten and aqueous sodium chloride using inert electrodes and write their half-cell equations. Next, we need to predict the products of electrolysis using appropriate examples. What is electrolysis? It's a chemical process that uses electricity for a non-spontaneous redox reaction to occur. This reaction takes place in electrolytic cell. Electrolytic cell is made up of two electrodes immersed in an electrolyte, and a direct current will pass through the electrolyte from an external source, a battery for example. Molten salt and aqueous ionic solution are commonly used as electrolytes. I am sure you are familiar with the diagram of an electrolytic cell, as you have learned this previously past year for SPM. We have one beaker, and in this beaker we have an aqueous solution, the electrolyte, and then inside this aqueous solution we will dip in an electrode. The anode is where the oxidation will happen, and the cathode is where the reduction is happen. So if you notice here, the negative terminal is the cathode and the positive terminal is the anode. So we are going to use a battery to supply the electron for this non-spontaneous reaction. Okay. Next, we are going to look at anode and cathode. Anode is a positive electrode, and this electrode is connected to the positive terminal of the battery, whereby oxidation will take place. Cathode, on the other hand, is the negative electrode, where it is connected to the negative terminal of the battery. Reduction takes place here. Electrons flow from anode to cathode. This is the same feature with the galvanic cell. Electrode. What is the function of electrode? It is a circuit connector. It works as a site for the precipitation of insoluble products. For example, we can also use platinum electrode, graphite electrode, those substances that is an inert. And electrolyte, on the other hand, is a liquid that conducts electricity due to the presence of positive and negative ions. Electrolyte must be in molten state or in aqueous solution so that the ions can move freely. For example, KCl, HCl, and acetic acid. What is the comparison between an electrochemical cell, a galvanic cell, and an electrolytic cell? Okay. In electrolytic cell, the solution is in one beaker, and the anode is a positive terminal. The cathode is negative terminal. But for galvanic cell, there would be two different solutions in two different beakers connected with a salt bridge, and the anode is the negative terminal, whereby the cathode is the positive terminal. In electrolytic cell, we have a battery But in electrochemical cell, we don't even need a voltmeter. The electricity or the electron will just flow through the wires. What are the similarities and the difference between electrolytic cell and galvanic cell? So in electrolytic cell, the cathode is negative terminal, the anode is positive terminal. Non-spontaneous redox reaction requires energy to drive it, i.e., we use battery. For galvanic cell, cathode is positive terminal, anode is negative terminal, and the spontaneous redox reaction will releases electrical energy through the wires, which will be detected by a voltmeter. And now, what is the similarity? Oxidation occurs at anode, reduction occurs at cathode. This is the same for both cells. Next, anion will move towards anode, cation will move towards cathode. Yes, that is also a general thing. And another one is electron will flow from anode to cathode in the external circuit, i.e. the wires. Ions to be discharged during electrolysis is based on three factors. Okay, the position of the ions in series. This is the series that you memorized last year, the electrochemical series or ECS. But now we are given table 2.4, the table where all the reduction potential are listed, so we don't need to actually memorize the ECS anymore. The principles here is that the more positive the E not red, the more likely it is to be reduced. Now, we need also to look at the concentration of the aqueous solution and also the types of electrode. Selective discharge of ions. So if we have multiple ions, metal ions and hydrogen ion are discharged at the cathode because they are cations, and negative ions are discharged at the anode because they are anions. Cation, which is discharged at the electrode, is the one that can gain electron most readily. The position of the positive ion in the electrochemical series is also one of the factors that affect the electrolysis. The more reactive the metal, the easier it can form cation. The order of the discharge of cations is the opposite to the reactivity of the metals. Metals which are less reactive have greater tendency to be discharged. Ions of metals which have standard reduction E not red more positive in the ECS are discharged in preference. So, same as galvanic cell, we are able to predict which part of the electrolysis cell that is going to increase in mass or produce more volume of gas. One thing that we also need to know is that the anion, which is discharged at the electrode, is the one that can lose electron most readily. And large resonance stabilized ions, such as sulfate and nitrate ions, will never be discharged under normal condition because hydroxide ions are discharged in preference. So if you see any sulfate ion and nitrate ion, they won't become sulfur gas or nitrogen gas. No, they are really stable as a large resonance polyatomic ion. So OH minus is going to be discharged instead. This is the ECS or electrochemical series, which I believe you already memorized last year. This time around, you can also use that memory of yours, but to be honest, we are going to give you the E not read from table 2.4 in the questions. So this ECS is not applicable anymore for calculation of our E cell. Determination of the species being discharged. How do we know which one will be discharged? So at anode, the species being discharged will be the species with the more positive standard reduction potential. So just like galvanic cell, we compare the species at cathode and the species at anode. Okay, so at cathode, where reduction will happen, the reduction potential or the E naught rate must be bigger, larger, or more positive. But at anode, the species being discharged would be the species with more negative standard reduction potential. So it has less value of E naught rate. It is more reactive. It would be discharged. Now, let's look at electrolysis of molten salt. In electrolysis of molten salt, only ions from the salt are present. So we would have no problem to choose between two ions which one is going to be discharged. In electrolysis of aqueous solution, on the other hand, there would be water molecules, and we have to choose between the ions or the H plus and OH minus that comes together with water. Electrolysis of molten salt looks like this. So we are going to do it on molten NaCl, Na plus a cathode. A cation will be attracted to cathode. So the reduction happens at cathode would be Na plus electron becomes Na. And the oxidation that happens at anode is the chlorine ion will becomes chlorine gas. So chlorine gas will be produced at anode. In the molten sodium chloride, only sodium ion and chlorine ion are present. I'm just reading it here. Sodium ion, a cation, will be attracted to the cathode and undergo reduction, whereas Cl- and anion will be attracted to the anode and undergo oxidation. In its molten state, sodium chloride, an ionic compound, can be electrolyzed to form sodium, metal, and chlorine gas. The reactions at the electrodes are, the oxidation is Cl- aqueous becomes Cl2 gas. And the cathode reduction occurs whereby Na plus aqueous becomes Na solid. What is the overall cell reaction? You can see here that they use 2 electrons, and we are going to get 2 Na plus aqueous plus 2 Cl minus aqueous and produce 2 Na solid plus Cl2 gas. So this is the overall cell reaction. This process is the major source of pure sodium metal and chlorine gas. This process is called Downs cell. This is the factory scale of how they do the extraction of sodium metal and chlorine gas. Downs cell is an important industrial process that produces sodium metal and chlorine gas from molten sodium chloride NaCl aqueous. Let's look at electrolysis of aqueous NaCl. NaCl aqueous solution contains Na plus cation, Cl minus anion, and water molecules. So during electrolysis, the cathode will be attracting Na plus ions and H2O molecules, meaning that it's not H plus, but it is H2O, because H plus in water will always be stick together with OH minus. And then for anode, it will be attracting the Cl minus ion and also H2O molecules at the negative part, oxygen part. So the electrolysis of aqueous NaCl depends on the concentration of electrolyte. So we look at the diluted solution first, whereby you can see here at cathode we have two options whether we want to choose Na plus or H2O. Look at the E naught red. You can see that the E naught red here is negative 2.71 volt for Na plus and negative 0.83 volt for H2O. The E naught red for water molecule is more positive. You can see this is negative 0.83, so it's higher. Therefore, H2O would be easier to be reduced. What will happen is we are going to get H2 and 2OH minus, because H2O is going to be reacting or receiving the electron. Okay, at anode, we are going to have Cl minus gas or water. Now we have to choose whether Cl minus or H2O is going to be reacting. So we look at the E naught. So this E naught is reduction form. It's a reduction form. You can see here electron is on the left. It is positive 1.36 for chlorine ion and positive 1.23 for water. So in dilute solution, water will be selected for oxidation because of its lower E naught red. E naught red for water is 1.23. It is lower than 1.36. So again here water is going to be reacted at anode. Okay, you can see there. The reaction involved in the electrolysis of dilute NaCl is, you can see here, cathode is 2H2O liquid plus 2 electron become H2 plus 2OH minus. And this is the E naught red. So we have to multiply this by 2 because at anode we have chosen also H2O, where oxygen gas will be produced together with 4H plus and 4 electrons. So because this is 4 electrons, we want to make an overall cell reaction, so we multiply the cathode half cell with 2 so that we get also 4 electrons. So now we're going to remove the electron and get the overall cell reaction down there. You can see that we have 4OH minus aqueous plus 4H plus aqueous. So this is basically 4H2O, right? So 4H2O, okay, potong dengan 6H2O over here, we get 2H2O over here. And this is the overall cell reaction for this electrolysis cell. So remember last year when you choose between Na plus and H plus? H plus, that one is not being used now because H plus will never be separated very far away from OH minus as a water. So we are not going to do H plus E become H2, not that one anymore. Here we are using H2O as a whole because they are not going to be separated very far in the aqueous solution. I hope you understand why we upgrade our level of things like this. Okay, so we know here that the E0 cell now is negative 2.06. Okay, we add them together. All right. Next is electrolysis of concentrated NaCl solution. You can see that at cathode, we have two options, Na plus and H2O. And these are the E0 red. Which one are we going to use? The ones with water molecules only, also, because it is more positive. So H2O will be easier to be reduced. And at anode is a bit different. Even though the E0 red for water is lower, Cl2 is going to be oxidized because of the concentration. In a concentrated solution, chloride ions will be oxidized because of the high content of Cl minus. Okay. Now, let's look at the equation. And the reaction involved is, as you can see, cathode 2H2O plus 2 electron become H2 plus 2 OH minus. And at anode, 2 Cl minus aqueous become Cl2 gas plus 2 electrons. So here we're going to involve with 2 electrons only. So this is the overall cell reaction. And then look at the E0 red there, it's listed, and the E0 cell here is negative 2.19. We just total them up. Okay, as you can see. Okay, the factors that affect the electrolysis products of an aqueous ionic solutions are listed. There are 5 factors. Okay, I think we have done this earlier, but then we don't realize it. So now we're going to read it out so that it's clear for us. Cation of less active metals are reduced to metal, including cations of aurum, argentum. Aurum is gold, argentum is silver, copper, chromium, platinum is emas putih, and cadmium. These cations will be reduced when compared to water molecules. Number 2, cation of metals from group 1, lithium, sodium, potassium, group 2, magnesium and calcium, and aluminium from group 13 are considered active metals. So water will be reduced. Next. Number 3, ions like Br minus, Cl minus, and I minus are oxidized when compared to water molecules. If the solution given is concentrated, it is more than 1 molar. So concentrated solution is 1 molar and above. Less than that is diluted. Oxo anions like sulfate ion, carbonate ion, nitrate ion, and phosphate ions are not oxidized because the central nonmetal of these oxo anions are already at higher oxidation state. So here, water will be oxidized. Number 5. Types of electrodes influence the selection of ions to be discharged. If a metal anode is used with its metal ions, the metal electrode will dissolve to form metal ions, which will then be discharged at cathode. So whatever element that is going to be discharged at anode and cathode, it is also depending on the types of electrodes that we use. Okay. That's it for electrolytic cell. For next lesson, we are going to learn how to calculate the mass or the volume of the product being discharged at anode and cathode. So I'll see you soon again for lesson 49. Thank you very much. Assalamualaikum warahmatullahi wabarakatuh. Bye.